A very warm welcome to you once again. Thank you for joining today's lecture. So we're continuing on from last time, Data Communications and Networks, lecture number 6 in section 2, which is the OSI model and the TCP/IP model. We'll focus our attention mostly on the OSI model because I feel that's probably the most important model you need to understand for your future to understand most aspects in networking. And if there is an issue, that's the best model you can use for diagnosing problems. So we finished the physical layer in the last lecture, lecture number 5. We finished on the physical layer. Now we're going on to the data link layer. So what is the data link layer? The data link layer establishes and terminates a connection between two physically connected nodes on a network. The data link layer transforms the physical layer, a raw transmission facility of ones and zeros basically, of voltage pulses. And we'll look at the details later on how the voltage pulses look like and so on and so forth. But for now, we need to understand the physical layers is built up of ones and zeros, right? Into a reliable link, which makes the physical layer appear error-free to the upper layers, because the whole idea is to be able to send data error-free to the other end, right? If data is distorted or corrupted, then there's an issue here, right? So the data link layer helps in this process, and so does the transport layer. And we will look at the kind of the role each of those layers play. Right? It breaks up the network packets it receives from the network layer. So we need to understand that we have a physical layer at the very bottom, which is layer number 1. Then above the layer number 1, we have the data link layer, which is layer number 2. Layer number 3 is the network layer, right? So basically the idea behind the data link layer is it receives information from the network layer above. And when we talk about the network layer, we basically call them as packets. So network packets are received from the network layer. And what the data link layer does is encapsulate those network packets into frames. So the nomenclature here or the terminology here is important to understand, and you'll see this terminology across different books, whether you're doing a Cisco course or you're doing other courses in networking, you will see the same terminology being used. So it's important to understand the slight differences in the way those that information is kind of portrayed to you. So at the layer number 3, we have a network packet, and this network packet comes down to the data link layer, and the data link layer adds its information for that specific layer and makes it into a frame and then sends it to the physical layer before it is sent to its destination, right? So it receives the network, basically it receives from the network layer, puts it into frames and sends them from the source to the destination. So this layer is actually composed of 2 parts. There's the logical link control, so you will see the abbreviation LLC, which represents the logical link control, which identifies network protocols and which also performs error checking and synchronizes the frame. So this portion of the data link layer, the link or logical link control, identifies the network protocols and performs error checking. So this portion of data link layer is responsible for error checking. Then there is the other portion of data link layer, which is called the media access control, or the MAC. This uses the MAC addresses. So you may have heard the term MAC address. The MAC address is at our layer 2, or resides at layer 2. Right? The media access control, which uses MAC addresses to connect devices and define permissions to transmit and receive data. So when you hear the term, once again, the MAC address, this is a layer 2. The switch that we had discussed before, when we'll try to learn more about switches and difference between switches and hubs. A hub is a physical layer device. It only understands ones and zeros. So that's a layer 1 device. It's not a very intelligent device, the hub, right? On the other hand, switches are way more smarter because switch is a layer 2 device. A layer 2 device understands MAC addresses. So switch understands MAC addresses and learns MAC addresses at each and every port. Okay, so we'll come more and kind of study more about the switches itself and how switches learn the MAC addresses and so on and so forth. But it's important to understand even at this stage that hub is a layer 1 device. It just knows ones and zeros, which is the physical layer. But while the switch is a layer 2 device, it understands MAC addresses. So it's a much more intelligent device. Okay. So now when we look at the data link layer, so we understand that above the data link layer is at layer 2. The network layer is at layer 3. So above the data link layer is the network layer. So basically the data link layer, which you can see over here, right? This layer here, receives information, which is the network packet from layer 3, which is the network layer. And then you can see the data which came from layer 3. Now it adds its own header information. The H represents the header. And then the trailer information, the T is for the trailer. It adds it to this network packet that it received from the network layer. And this information is now referred to as a frame. So a frame happens when information from the network layer is received and then encapsulated in the header and trailer information of the data link layer. And then this frame is then passed on to the physical layer. So this is the sender here on this side. Now this information is sent from the sender to the receiver. Once the information is received on the receiver side of things, right? So from the physical layer, the information makes it to the data link layer, where here you'll see that the header is taken off. So this is a de-encapsulation process. The header is stripped off and the trailer is stripped off, and only the relevant network packets data is sent to the network layer. So you can see the process coming from the network layer above to the data link layer to the physical layer, and conversely on the other side, the information going from the physical layer to the data link layer to the network layer. The most important information in here, as we mentioned here, is the MAC address, which is going to be part of the header. And then there is the error checking, which we talked about. The logical link controller is responsible for error checking. The error checking information is in the trailer, right? So we have the MAC address information in here, which determines the source MAC address. So where is the information coming from? And the destination MAC address, where is it going to? And the error information to make sure that this frame has been received intact and there is no issue with this specific frame. So let's look at this process, or let's try and understand a little bit of this process. The framing process. The data link layer divides the network packets received from the network layer into manageable data units called frames. The media access control is responsible for physical addressing, so physical address, okay, which is basically the MAC address. It's also referred to a physical address. If frames are to be distributed to different systems on the same network, the data link layer adds a header to the frame to define the sender or the source MAC address and the receiver or the destination MAC address. So every time a frame is composed, it needs to have information about who is the sender in terms of the MAC address and the receiver, who is the receiving MAC address, right? So these two pieces of information are in the header. And as I mentioned, in the trailer is the error checking information. If the frame is intended for a system that is outside the sender's address, beg your pardon. If the frame is intended for a system outside the sender's network, the data link layer adds a header to the frame to define the sender's source MAC address. So the source has to be there, the sender's source MAC address. And the destination MAC address in this case is going to be the next hop. So you can see slight differences in here. In the first case, you could see that if the receiver is on the same network, then the information being encapsulated here is going to be the receiver or destination MAC address. But if you have the receiver who is outside the network, the sender's network, then the destination MAC address is the MAC address of the next hop. So which is where can this frame be sent to so that it gets to the right destination. So it's going to send this information to a router, could be a load balancer, could be a proxy server, could be a NAT device. So we'll talk about all different aspects in later lectures. But to understand here is that the slight differences in how things are handled. So the source MAC address always has to be there, or the sender's MAC address always has to be there. But the destination MAC address will depend on where the destination happens to be. If the destination is on the same network, then it will put in the receivers or the destination MAC address of the receiver who it's being sent to. Otherwise, if the destination or the receiver is outside the network, then it has to figure out, okay, how do I get to that other machine that is not on the same network? For example, it could be you're trying to get to the internet. The internet is not on the same network as we are, for example, at home or in the office, right? It's going way out to the internet to get to, let's say, Amazon.ca, Amazon.com, Google.com, Google.ca, right? So it needs to understand how can I get this information out there to the internet. So it'll send this information to the next hop, which is going to be the router. In your case at home, it could be basically your home router, right? So that's going to be your next hop. The information in order to get to the internet will leave your machine, your PC, your Windows machine, your Mac machine, your Linux machine. It'll go to the next hop, which is going to be your home router. So that's going to be your destination MAC address for now if it needs to go to the internet. We'll talk more as we go along. So your home router, in this case, you see the word router in here, is basically going to be your next hop address if you are leaving your machine to go out to the internet. Then there is the data link layer, right? The data link layer is the other portion of the data link layer we mentioned was the logical link control. So this logical link control is responsible for flow control, error control, and access control. So in terms of the flow control, if the rate at which the data are absorbed by the receiver is less than the rate at which data are produced by the sender, then so the rate at which the data are absorbed by the receiver is less than the rate at which the data are produced by the sender, the data link layer imposes a flow control mechanism to avoid overwhelming the receiver. So if the receiver is unable to process that information, it will try and impose a flow control mechanism to say, hey, wait up, slow down, please. I cannot process all this data. Can you slow down and send these frames slowly, right? Then there is the error control component. The data link layer adds reliability to the physical layer by adding a mechanism to detect and retransmit damaged or lost frames. It also uses a mechanism to recognize duplicate frames as well. So the error control is normally achieved through a trailer added to the end of the frame. So we saw the trailer at the end. This is responsible for error control. And then there is the access control. When two or more devices are connected to the same link, data link layer protocols are necessary to determine which device has control over the link at any given time. So what does the data link layer MAC address look like? This is what the MAC address will look like. Okay, so we'll continue on next time. Thank you for joining today. Take care. Have a great day and hope to see you next time. Bye-bye.